Welcome to Unit 5, More CPU Scheduling. Today we're going to talk about multi-level queue and multi-level feedback queue. And basically what that means is that in your system you have different processes that have different scheduling algorithms. So you may have some processes that are using round robin with time quantum 10, some round robin with time quantum 20, and some first come first serve or whatever, like the diagram has. And if you use multi-level queue, that means if it's a Q1 process, it uses round robin with time quantum 8, and it always uses round robin with time quantum 8. But if you have multi-level feedback queue, it means it may, for different reasons, it may migrate to a different queue and use a different algorithm. So that's the only difference. In multi-level queue and multi-level feedback queue, you still have different algorithms for different processes on your system, but in multi-level feedback queue, for different reasons, a process may migrate to a different queue. Now in your CPU scheduler programming assignment, it will be multi-level feedback queue. And in this video, I'm going to do an example of multi-level queue. Just keep in mind as we go through these examples and you work on your CPU scheduler, these are not standards. I have given you descriptions of an algorithm and we are following the specified descriptions, but anyone can make up any type of multi-level feedback queue or multi-level queue that they want and describe how it should be done, and then that could be a different exercise or a different implementation. So let's get started. It happens to be a multi-level queue exercise. And what we have here is we have two queues. So if you look at the priority queue column, you can see that P1 is a priority Q2 and P2 is a priority 1. And if any process has a higher priority, it will preempt a lower priority process. And P1, since it's a Q2, it will remain a Q2 and it will not change because this is multi-level queue and not multi-level feedback queue. So if a process is a Q1, it has a round robin with a time quantum 4, and if it's a Q2, it has round robin with a time quantum of 3. So let's get started. We will start at time 0, and if you take a look at the arrival times, the only process that has arrived at time 0 is P1. So P1 uses round robin with a time quantum of 3. However, since it's a priority 2, we need to check at each time unit, time 1, time 2, for the arrival of a priority 1. But since the priority 1 does not arrive until time 3, P1 will get to finish its complete time quantum. So P1 has finished its time quantum and now the current time is 3. And so if you look in our ready queue, we have a P1 and we have a P2, and P2 has a higher priority. So P2 is going to go and it gets a time quantum of 4. So P2 will go for its time quantum of 4, but if you recognize that at time 7, there's only a Q1 and one Q2, then P2 is going to continue to complete its entire 7 time unit of CPU burst. So at time 10, P2 has completed all of its execution. Now the current time is 10, and in our ready queue, we only have P1. So P1 will go, but if you notice at time 12, we will have the arrival of P4, which is a priority 1. So P1 will be preempted at time 12, at which time we will run P4. P4 is a level 1 and it gets a time quantum of 4, but because it's the only level 1 at time 16, P4 will continue, and P4 has now completed all of its execution at time 17. Now the current time is 17, and in the ready queue we have P1 that got there at time 12 and P3 that got there at time 4. So what we're going to do is we're going to run P3 because P3 got there sooner and round robin is first come first serve, but we will have P5, which is a priority 1, arrive at time 18. So P3 will be preempted at time 18 and P5 will now go. And since P5 is the only level 1 left, P5 will get to do all of its 8 time unit of CPU burst, and P5 will finish at time 26. Now the current time is 26, and all we have left in our CPU are P1 and P3, both of which are priority level 2s, so they are just going to round robin with, take turns round robin with a time quantum of 3. So now we will have P1, which will go until time 29. Then we have P3, which will go until time 32. Then we have P1, which will go in time till time 34, and P3, which will complete all of the execution of all the processes at time 36. Now, once we get the Gantt chart, we can then calculate the results. So we will start with P1's response time. P1 arrived at time 0, and the first time it got on the CPU was time 0. P2 arrived at time 3 and got right on the CPU. P3 arrived at time 4 and had to wait until time 17 to first get on the CPU. P4 arrived at time 12 and got the CPU right away. P5 arrived at time 18 and got the CPU right away. And now we can do the turnaround time. Oh, we can calculate the average by adding them up and dividing by 5. And now we calculate the turnaround time. P1 finished at time 34 and arrived at time 0. And the wait time, so P1 spent 24 time units waiting and 10 time units on the CPU. P2 completed execution at time 10 but arrived at time 3, so was active in the system for 7 time units and never had to wait at all. P3 finished at time 36 and arrived at time 4, so was active in the system for 32 time units and waited 26 of those time units. P4 was active in the system for 5 time units and didn't wait at all. And P5 was active in the system for 8 time units and didn't wait at all. And then you can take these numbers, add them up, and divide them by 5, and you can get the averages. So this is an example of multi-level queue. The processes do not change from their queue. They stay in the same queue the entire time. And they have different algorithms. If it's a Q1, it had a different algorithm than if it was a Q2. And Q1 had higher priority, so if there was a Q2 on the processor, it would be preempted by a Q1. And this is an example of an exercise that I will be posting on Blackboard with the solution for you to try. It has first come, first serve, shortest job first, multi-level feedback queue, and preemptive priority. So this will be posted for you to try and look at the solutions, and then you can use you only use the priority column for the number 4 algorithm, which is preemptive priority. Other than that, you use the queue column for the multi-level feedback queue, and you don't need to worry about the queue column or the priority column when doing first come, first serve, and shortest job first. And this is also similar to your CPU scheduler algorithm where you will have CPU, IO, CPU. So if you take a look at P1, P1 does 5 units of CPU burst. When it has completed its 5 units of CPU burst, it will then go to IO for 6 time units, and then it will go back after completing IO, get back in the ready queue, and do its 7 units of CPU burst. So I will take a look at the solutions and ask me if you have any questions. Thank you.